All right, welcome everyone back to our study of radicals. Today we're going to be looking at our third lesson, and this is binomial radical expressions. We've dealt with the word binomial in previous chapters, previous units, and we're going to look back and see what that means in a moment. We're going to be looking today at addition, subtraction, multiplication, and division of these things. So let's go ahead and take a look back at what a binomial means. In general terms, a binomial means an expression with two terms or two things. Our most very easy example here is 2x plus 3. This is a polynomial with two terms, hence the name binomial. The bi means two. In addition and subtraction of binomials, you're only allowed to combine like terms, and this goes as well to our radical expressions we're going to look at in a moment. If we were to have this particular problem right here, where we were to add these two binomials together, we would add the like terms together. So the like terms being 2x and x, so 2x plus x is 3x, and 3 plus negative 5 is a negative 2. Right? So combining using addition is not a challenging concept, and it's not that challenging in the world of radicals either. If you were to multiply two binomials together, that is the FOIL method. We call it just the FOIL method, as that's how to multiply. Taking 2x plus 3 times x minus 5, we might remember that when we multiply, we FOIL. Let's see if we can get this thing to work here. There we go. 2x times x becomes 2x squared. 2x times minus 5 is minus 10x. 3 times x is a 3x. And 3 times minus 5 is minus 15. And as always, after we multiply, we have to simplify our expression. So we have 2x squared minus 7x, because we combine like terms, minus 15. Now, when we get to division, things get a little bit weird in the study of even polynomials and in radicals. In polynomials, division, we have to use either synthetic division or long division. But in radicals, it's completely different, and it actually more follows our study of complex numbers. If you remember that, you'll remember what we do when we get there. I'm going to leave off on this because division doesn't have one set way of solving the problems, as the other two or the three do. So let's take a look at what we're going to look at with radical expressions. When we add or subtract radical expressions or binomial radical expressions, we are going to only be able to, well, again, we have to combine like terms, but we're only going to be able to add the radicals that have the same index and the same radicand. Radicand being the number on the inside of the square root, or the radical itself. And they're going to work like variables in general. So if I had the square root of 2 plus the square root of 2, these have the same index, which is 2, and the same radicand, which is also 2 in this particular case. If we were to add them together, they're going to work like variables. So if I have one square root of 2 and another square root of 2, I have a total of 2 square roots of 2. Likewise, if we had 3 times the square root of 7 plus 5 times the square root of 7, I have 3 root 7 and I have 5 root 7, and those have the same index and they have the same radicand, and therefore I'm going to add as I would variables. This is 3 of something and 5 of something, so I have 8 of those somethings. if we were to do something like this, looking now at the binomial terms, if I had 3 times the square root of 5 plus 2, and I was to add it to 7 minus the square root of 5. This is now adding two binomials together, but we can only combine like terms. So the 2 and the 7 can be combined, and we have a positive 2 plus a positive 7, so we get a positive 9. And we have a 3 root 5 and a negative root 5. Well, they're the same radicals, they're the same index and the same radicands, so we can combine them. A 3 root 5 plus a negative 1 root 5 becomes a positive 2 root 5. And then we have the combined answer. If, let's say we had the cube root of 3 plus the square root of 7 minus 3 times the cube root of 2. Oops, sorry, not 2. Oh, man. I'll start with that one over. Cube root of 7 minus, or let's say plus, the square root of 5 minus 3 times the cube root of 7 plus 2 radical 5. We can combine like terms if we have them. We do. We have the 2 cube roots that have the same index and the same radicand, so we can add them together. We have a positive 1 root 7, cube root 7 minus 3 cube root 7, which means I have a minus 2 times the cube root of 7. And I have a plus root 5 and a plus 2 root 5, so I get a plus 3 root 5. Now, we could get a little bit more complicated in problems such as this. If I had the square root of 8 plus the square root of 2. Now, this doesn't look like they have the same radicand. However, the square root of 8 can be simplified. The square root of 8 is really the square root of 4 times 2, which becomes the square root of 2 root 2. Or sorry, 2 root 2. Then we can add the root 2 and get a total of 3 root 2. So in some cases, they might not have the same radicand, but you are allowed sometimes to simplify the radicand if possible, and you might end up with the same radicand that you can, or the same root, so you can combine them. All right, so I think I have beat into you addition and subtraction. Let's take a look at multiplication. In multiplication, you're going to have to remember to FOIL, and you're going to have to remember that we can multiply together our radicals themselves. So if we were to take the square root of 2 plus 1 times the square root of 3 plus 2. We must FOIL these two things together, and we are allowed to multiply these radicals together because they have the same index, as we remember from the last lesson. When I do root 2 times root 3, I get the square root of 2 times 3, which becomes 6. Then I'm going to do 1 times 2, which is 2. Then I'm going to do root 2 times 2. Now, 2 times root 2 is like multiplying variables to a number. 2 times radical 2 is just 2 radical 2. And then we can have 1 times root 3, which is just a root 3. And as always, you must try to simplify if you can, if there's anything that you can simplify together. Well, it just so happens there's nothing alike in this particular problem, so our final answer is actually what we wrote. There's nothing to simplify in this particular problem. But let's look at something a little bit different. If we had 1 plus the square root of 3 and 1 minus the square root of 3. Now these are very handy numbers to know. That whole minus sign in between, we call them conjugates. We're going to look at that in a few minutes here. If we FOILed these two numbers together, we get 1 times 1, which is a 1. 1 times minus root 3, which is a negative root 3. Root 3 times positive 1, which is a plus root 3. And then we get a positive times a negative, so that's minus. Root 3 times root 3 is the square root of 9 because 3 times 3 is 9. And then we notice what happens when we simplify. We get the 1. But here, the minus root 3 plus root 3 cancel. And then the square root of 9 is 3. So we get minus 3, and we simplify there to get a negative 2. So notice that we go from radical expressions down to a whole number, or an integer. When you multiply these two things together, these are conjugates. When you multiply two conjugates together, you get a nice whole number. That plays a huge role in the next piece, which is division. When you divide when you divide radical expressions, binomial radical expressions, it's like division of complex numbers where you must multiply by the conjugate of the denominator. And that needs to go to both numerator and denominator. And what this does is it rationalizes the denominator as we learned in previous lesson. So if we have 1 plus the square root of 3 over 2 minus radical 2, we need to multiply by the conjugate of the denominator. So the conjugate of the denominator is just 2 plus radical 2. And we have to do that to both top and bottom. Well, now we have binomial times binomial, which means we have to FOIL some more. So when we FOIL the numerator, 2 times 1 is 2. 2 times root 3 is a plus 2 root 3. 1 times root 2 is a plus root 2. And root 3 times root 2 is a plus root 6, as we remembered in the last problem. Then we go 2 times 2 is a 4. 2 times minus root 2 is a minus 2 root 2. 2 times positive 2 is 2 times a positive root 2 is a plus 2 root 2. And then minus root 2 and plus root 2 make a minus 2, which we can then simplify. Well, the numerator doesn't really do anything. And then the denominator will simplify this and this. You know what I need to write is that this root 2 times root 2 is a square root of 4, just in case you missed that. The square root of 4 is 2. 4 minus 2 becomes 2, and notice the denominator is now nice and simple. If we were to distribute this dividing by 2, so we can get rid of the fraction bar, we get 2 over 2, which is 1. 2 over 2, which is 1 root 3. We get 1 over 2, which is 1/2 of root 2. And then root 6 over 2 is just a 1/2 of root 6. Because that number in front is just a 1. All right, rather than doing mini examples, you are going to have examples in your book that you are going to be able to follow and practice. All right, so hopefully you learned quite a bit of stuff in this lesson, and I will see you guys later.